Picture this. The year is 1964, and the world is introduced to Eliza, a machine capable of mimicking human conversation. This remarkable innovation was the brainchild of Joseph Weizenbaum at the Massachusetts Institute of Technology. Eliza, unlike anything before, used a technique called pattern matching and substitution methodology to simulate a conversation. It worked like this. Eliza would recognize phrases and keywords, then respond based on a set of pre-programmed rules. For instance, if you mention feeling unwell, Eliza might reply, "I'm sorry to hear you're not feeling well." While this may seem quite basic to us now, it was a significant milestone in the field of natural language processing, or NLP. Eliza was the first of its kind, a pioneer sparking curiosity and inspiring future exploration into how machines can understand and generate human language. Eliza may seem rudimentary by today's standards, but it was a groundbreaking achievement that laid the foundation for future NLP developments. A fast forward to the 21st century, and we see a dramatic shift in NLP capabilities. Our first stop is the bag of words model, a simple yet effective method. It represents text as a bag of its words, disregarding grammar and word order, but keeping track of frequency. However, it falls short in capturing context and semantic relationships between words. Then we have the TF-IDF model, short for term frequency inverse document frequency. It's a step up from bag of words, giving more importance to words that are less frequent in a corpus, thus helping to highlight the uniqueness of a document. Still, like bag of words, it neglects the context and semantic relationships. To address these shortcomings, word2vec comes into play. This model learns to represent words in a high-dimensional space, capturing semantic and syntactic relationships between words. For instance, it can infer that king is to man as queen is to woman. But it's not all roses. Word 2, vec struggles with words having multiple meanings, and it doesn't consider the order of words. Enter long short-term memory, or LSTM. This model is a type of recurrent neural network that can understand the context and maintain long-term dependencies in a text, addressing word 2 vec's limitations. However, it gets computationally expensive when dealing with longer sequences. Finally, we arrive at GPT-3, the current superstar of NLP. GPT-3, or Generative Pre-trained Transformer 3, leverages the power of transformers and machine learning to understand context, generate human-like text, and even answer complex questions. It's the closest we've come to human-like understanding, but it's not perfect. It requires vast amounts of data and computational power, and it can sometimes produce nonsensical or biased outputs. From simple pattern matching to context-aware models, the evolution of NLP has been nothing short of astounding. And as we continue to strive for models that truly understand human language, who knows what the next milestone in NLP will be? Now we stand at the forefront of NLP with GPT-3, a model that has taken the world by storm. This AI powerhouse, developed by OpenAI, is a language model that has redefined the boundaries of what's possible in natural language processing. GPT-3, or Generative Pre-trained Transformer 3, is a behemoth with an impressive 175 billion parameters, dwarfing its predecessor, GPT-2, which had a mere 1.5 billion. This leap in scale has resulted in a model that is capable of generating human-like text that is often indistinguishable from something a person might write. But GPT-3 is not just a text generator, it's a multi-talented model that can translate languages, answer questions, and even write poetry. Give it a prompt in English and it can respond in French. Ask it a question about a complex topic, and it can provide a detailed, nuanced answer. Request a sonnet about the moon, and it will craft verses that would make a poet proud. What sets GPT-3 apart is its ability to learn from a massive amount of data and generate accurate and coherent responses. It's not just about stringing words together, it's about understanding context, capturing nuances, and creating output that makes sense. This deep learning capability has revolutionized NLP, bringing us closer to the dream of machines that can truly understand and generate human language. But as impressive as GPT-3 is, it's not perfect. It can sometimes produce inaccurate or biased content, and it doesn't truly understand the text in the way humans do. It's a reminder that while we've come a long way in NLP, there's still a journey ahead. GPT-3 has pushed the boundaries of what we thought was possible, but what does the future hold? As we continue to innovate and refine our models, we're not just asking machines to understand language, we're exploring the very nature of communication and comprehension. The story of NLP is far from over, and the next chapters are sure to be even more exciting. Looking ahead, the potential for NLP is limitless. Imagine a world where language barriers are a thing of the past because machines can flawlessly translate between any two languages in real time. This isn't just about ordering dinner on your next trip to Paris. It's about fostering global understanding and collaboration on a scale we've never seen before. In the realm of sentiment analysis, we're not far from the day when machines can read between the lines, understand sarcasm, detect subtle shifts in tone, and respond accordingly. This could revolutionize how we interact with technology, adding a new layer of emotional intelligence to our devices. Conversational AI is also on the brink of a major breakthrough. We're moving from simple command and response interactions to a future where chatbots and voice assistants can carry on dynamic, context-aware conversations, just like a human would. This could transform customer service, making it more efficient and personal than ever. But the impact of NLP goes beyond our daily interactions with technology. Consider the healthcare industry. NLP could help doctors sift through mountains of patient data, identify trends, and make more accurate diagnoses. It could even enable real-time transcription and analysis of doctor-patient conversations, providing immediate insights and recommendations. The future of NLP also promises to address some of the ethical concerns that have arisen. With more advanced models and better training data, we can strive to eliminate bias and ensure that these technologies are fair and respectful of privacy. But perhaps the most exciting prospect is that we're inching closer to a future where machines can truly understand and engage with us on a deeply human level. Not just understanding the words we say, but the nuance, the context, and the intent behind them. This is the next frontier in NLP, and it's one that could change our world in ways we can only begin to imagine. As we continue to push the boundaries of NLP, we inch closer to a future where machines can truly understand and engage with us on a deeply human level.